All right, this is a supplement to section 13.4. For some reason, my second video cut off before I actually got to get this example. I recorded it, or at least I thought I did. Um, Probably be about a 5-minute video here. And I don't usually do things this way, but since I actually already thought that I recorded it and it didn't come through, I'm just going to go ahead and use the notes that I've already put on here. So the example says a gun has a muzzle speed of 150 meters per second. Find two angles of elevation that can be used to hit a target 800 meters away. So 800 meters is half a mile. It's a pretty long distance. Um, so there's two angles of elevation that can be used to hit this target if you have a gun with a muzzle speed of 150 meters per second. So what we're going to do is we're going to start off with writing down what we know. We know the magnitude of the initial velocity is 150 meters per second. We know the distance that we're trying to get is 800 meters. Okay, we also know that the x distance can be written as magnitude of the initial velocity cosine of alpha times t. And in our case, the magnitude of the initial velocity was 150, so we're substituting that in right here. And then we know that the y distance can be written as magnitude of the initial velocity sine of alpha times t minus 1/2 gravity times t squared. And again, we know that our initial velocity is 150, so we substitute that in. All right, so now the y distance, we want that to be 0. We want there to be no height because I guess we're assuming that this target is on the ground 800 meters away because it doesn't say it's got any kind of height to it. So we're going to assume that we want y to be 0. And if that's the case, we know that for y to equal 0, we can factor a t out. Should have probably written equals 0 out here on the side. But we'll know that t is either equal to 0 or setting all of this stuff here equal to 0 and solving for t, we get that t equals 2 magnitude of the initial velocity sine of alpha over g. Now keep in mind, by the way, in this problem, we are not using pi force or 45 degrees here because we are not finding the maximum distance. We're actually trying to hit a target that's a specific distance away. If we wanted to maximize the distance, we would have just used pi force with our x of t formula and we would have been good to go. All right. Again, I'm looking for that maximum x, not the maximum, I'm looking for the x of t because that's going to help me find the angle. Remember that x of t is magnitude of the initial velocity cosine of alpha times t. But what I did was I solved the y portion for t, so I can substitute that value in here for t, which is going to allow me to use that 2 sine cosine combination to write sine of 2 alpha. And then I've still got this magnitude of the initial velocity times itself, because here's one and here's another one. So that gives me the squared, and then all of that is over g. And we want that to equal 800 because we're trying to find this angle that's going to create that 800 distance. So in order to solve, we're going to multiply both sides by g and then divide by the magnitude squared, which is what we have here. And then in order to solve this, we need to basically take the wow, just drawing a blank. Well, first of all, we have to simplify this. So 800 times gravity, 9.8, divided by 150 squared is going to end up being 0.348444. Then we have to figure out what the angle is going to be. So the 2 alpha has to equal the inverse sine of this, and put it in degrees because we're going to do this in degrees, not in radians. So we'll take the inverse sine of this number right here, this 0.348444, and set that equal to 2 alpha. And when we get an actual value out of this, whatever this gives us in the calculator, we'll divide that by 2 to find the actual alpha, which works out to be 10.196 degrees. That is this lower one right here. It's a relatively small angle. So it's a pretty low angle. This thing is going to come out here and be able to hit a target 800 meters away. Now, what it said at the top is that we have two angles, and that's true because there's going to be another angle where you could launch this thing way up in the air and then have the bullet or whatever, the rocket or whatever this thing is, come right back down on the 800 feet. So this is going to be a supplement to this one right here. So basically all you have to do is take 90 and subtract the 10.196, and you'll get the other angle to be 79.804. And it can't be more than a supplement, because if it's going to be something outside of 90 degrees, you're shooting backwards. So it's got to be the supplemental angle right here. All right, that should pretty much do it. Again, I don't know what happened, why it didn't record the initial video, but here's our supplemental video.